I talk a lot about statistics, but I usually talk about the abstract and how that relates to human nutrition science, and I critique a bunch of bullshit studies because they're bullshit. I wanted to actually get into some examples here to show you exactly how these studies are actually done, what the questions kind of look like in the context of human nutrition science, and how to solve them yourself so that, once you know how to solve them, then you kind of know how to interpret them on paper. So I got ChatGPT to just make some examples, and I looked at them and I said, oh, these are actually some really good examples. So let's go ahead and follow them, and let's actually get into what this stuff really means. A study measures added sugar intake for a random sample of 40 college students. Okay, so the variable that we're looking at right now is a sample mean. So you've got sample proportions, which are sort of binomial functions, and then you've got sample means. Sample means are typical, as you can see, average sugar intake, average fiber intake, reported fiber intake, reported sugar intake. Lots of noise here. But it doesn't change the fact that it is still something that needs to be understood, of course. So this is the traditional sort of approach, is using sample means instead of sample proportions, but it does depend on the type of study you're looking at. So we've identified what variable this is. Okay, it is a sample mean. For a random sample, simple random sample of 40 college students. Okay, so N of 40. So now we know the sample size we know the sample size. So we don't know the population size. We'll get into what the population even really means in the first place, okay? So the sample mean is 75 grams a day. Okay, so now we know the mean with a sample standard deviation of 18 grams. Okay, so a sample standard deviation, not a population standard deviation or anything like that, because there is a distinction. Basically, a sample is a subset from a population. A population. Hypothetical population, actually. Completely hypothetical because you haven't measured it, which is why you're performing the sample and forming confidence intervals in the first place. We'll get into what those mean in a minute. So, construct a 95% confidence interval for the mean added sugar intake in the population. Okay, so this is like textbook level. This is really, really simple stuff. Okay, really simple. So, let's actually get into this. Great, let's tackle problem 1. Okay, so we know that the average sugar intake as reported, because that's what actually matters here, of a sample of 40 college students, N equals 40, is 75 G per day plus or minus 18 G per day. Good. I mean, this is simple stuff, right? This is pretty self-explanatory. So, in order to construct a confidence interval for a confidence level of 95%, we will need to calculate the standard error for the sampling distribution of the sample mean. Okay, so what does any of that mean? Okay, what does any of this mean here? So let's cover what a confidence interval even is in the first place. So a confidence interval is an interval range whereby you are purported to have 95%, 90%, 85% confidence. That's what the confidence level is. You actually arbitrarily choose that. That's fine. That's up to you. That's actually normal. You're supposed to be able to arbitrarily choose that. But typically it's 95% because of the geometry of a distribution curve. You're purported to have 95% confidence that the sample mean in that population that you are studying, whatever that population is, it's entirely hypothetical, will lie within that range. It is the range whereby you are purported to have 95% confidence that the sample mean, if you were to conduct the study again and again and again, will actually lie within. So if you were to conduct an infinite number of samples on this hypothetical population, you will yield all of your sample means will lie within that range 95% of the time. That's how you should think of it. Okay, that's what this is about. So this is inferential statistics, and if you have binged my videos which you should have by now. If you haven't, now's your time to do so. You will know that I'm quite jaded against inferential statistics. Not the science itself, it's actually the false application of this science to things like human nutrition science when your cases are not identical in characteristics and are subject to completely different confounding and or spurious variables with different behavior that varies day to day, minute to minute, as a function of time. Okay, that is not appropriate. However, this is to show you, this is to walk you through how to do this, because I know how to do this stuff. I know what is going on here, even if I don't like it. And that's what I'm here to tell you. So it's telling me to construct a 95% confidence interval around that sample mean. And there's ways of doing that. This invokes the central limit theorem. It's a very dense topic, but I already covered what the main thing that we have to do is, which is calculating the standard error for the sampling distribution of the sample mean. So what is the standard error? The standard error is the estimated standard deviation in the sampling distribution of your sample mean in this case. So what does that mean? Well, remember when I said that if you take an infinite number of samples from a hypothetical population, you will form a sampling distribution with the x-axis equaling all of the sample means, and then the y-axis being the incidence rate of all those means. Okay, like how many times you actually acquired said mean. Well, if you do an infinite number of samples and that sample size is greater than or equal to 30 in this context, and or the random variable in the population you're trying to extrapolate to is approximately normal in its distribution, you will get a sampling distribution of a sample mean that has a mean equal to the population mean and a standard deviation equal to the standard deviation of the population divided by the square root of your sample size, n. But you don't know the standard deviation of your population, so you have to estimate it. So this is where you get the standard error, which is your sample standard deviation, not your population standard deviation, but your sample standard deviation divided by the square root of n. So that's what we're going to do here. Okay, we're going to take the sample standard deviation here, which is 18 grams, which is 18 here, and we're going to divide it by the square root of n, which is your sample size. Okay. Now, good thing it's greater than or equal to 30, or else then it would actually be irresponsible to do this. You wouldn't be able to infer about population. And those criteria vary depending on if you're studying a sample mean or if you are studying a sample proportion. So we're going to go ahead and calculate this. So we get a standard error. I'm doing it on my phone calculator here, just a normal kind of thing, of 2.85. The standard error is 2.85 grams per day. Now, what does this mean? Well, as soon as you have a standard error, you now need to calculate your margin of error. Why? Well, why is there a margin of error? Well, because if you're trying to form a 95% confidence interval, it would be really easy if you just knew the parameters of the population, because then you'd refer to that sampling distribution, and you would just find where 95% of the area of that curve is. You would just find the x values that encompass 95% of the area of the curve, and that's your 95% confidence interval. But you don't know the standard deviation of the sampling distribution, so you have to estimate it. Well, every estimation is built on an assumption, and every assumption introduces error. So that's why you have a standard error, but that's also why you have a margin of error. This error always sort of manifests itself as a probability distribution. In this case, it would be the t distribution. Now, the t distribution is characterized by degrees of freedom. Degrees of freedom is equal to the sample size minus 1, so we know that this t distribution in this situation is going to have 39 degrees of freedom, basically. And what you're supposed to do is find a corresponding t-score to a t-table for your specific t distribution, which is again characterized by the degrees of freedom. So what we're going to do here is we have the standard error, and we need to multiply this by a t-score. Now, t-scores are only relevant to sample means. They are not relevant to sample proportions. So we're going to actually open up a different chat here, and we're going to say, what is the t-score for a 95% confidence level, because that's what matters here, confidence level, and for a t distribution with 39 DF is what we're going to put, because that's typically the abbreviation there. So what is the t-score for a 95% confidence level and for a t-distribution with 39 degrees of freedom? I believe that's really all we need to know. I need to see. Yeah, so it's going to be a two-tailed test here. DF equals 39 from the t-distribution table or using statistical software. That's really what we should be. Yeah, it's going to be using software. So tables usually are in increments of 10 degrees of freedom. And so if you're looking for 39 degrees of freedom, you would choose the closest lower value of that. So that would be 30. But since we actually have statistical software here, we can actually just look at the exact value, which is important and helpful. And so we see that there is a t-score here of 2.0227. So what we're going to do is we're going to go back to our standard error, and we're going to take 2.85 and multiply it by that value. So actually I need to go back to look at the 2.0227. All right, so our margin of error is 5.76. So 5.76, what does that mean? That means that if we were to construct our 95% confidence level, or confidence interval, we would take the sample mean, so that was 75. So actually what we need to do first is, this means that our margin of error is 5.76. This means that our confidence interval for a 95% confidence level I can't type. For a 95% confidence level is going to be the standard, or is going to be the sample mean plus or minus. So in other words, that would be this symbol here, the margin of error, which is, so that's the answer. That's the answer. Our 95% confidence interval is going to be the sample mean plus or minus our margin of error. Okay, so let's do, so we have it on our calculator here, mine here. And so we're going to add that, we're going to actually negative that, and we're going to add, what's the 75? So 75. So 69.24. So we'll actually just type that in here. 69.24 grams. And really, I kind of want to round it to 69 grams, but to be extremely exact, I'll put it that way, which is 69 G per day, semicolon, and then we'll list the next value, which is 75 plus 5.76. So 75 plus 5.76 is 80.76 grams per day. In other words, we can be, so yeah, the question becomes, what does this actually mean in simple terms? We'll put a little scene break there and say, in other words, we can be 95% confident that our sample, or that our population mean, rather. You know what? Let's rephrase it even differently. We can be 95% confident that the mean of the variable in the population is between 69.24 and 80.76. Oops, 80.76 in terms of added sugar intake per day. Now, if you're going to be an actual responsible scientist, what you would do is you would say, in a population that shares very similar characteristics and really identical characteristics and is subject to the same confounding and spurious variables that share the exact same behavior across time. Inferential statistics is ridiculous in this field, but I know how to do it anyway. Okay, and this is what I'm showing you. This is the math that's involved. To be fair, there's not really that much pseudo-sophistication going on. These are based on actual mathematical proofs and theorems. It's just being applied inappropriately. Apply this in engineering and you're fine. Apply it to human nutrition science, not the case. So let's go ahead and see what ChatGPT has to say about this. Okay, I might have done I might have done some math wrong, but I really don't think so. I mean, let's just read this through first. Let's tackle problem 1. We know that the average sugar intake as reported of a sample of 40 college students, n equals 40, is 75 grams per day, plus or minus 18 grams per day, mean plus or minus standard deviation. And by the way, if they're going to report mean plus or minus SD, usually that means, and it should mean, that the random variable is normally distributed. So let's hope that it actually was, or else they should have reported a mean plus or minus MAD, and then things get more complicated. But anyway, in order to construct a confidence interval for a confidence level of 95%, we will need to calculate the standard error for the sampling distribution of the sample mean, and we already covered what that is. The standard error is 2.85 grams per day. So that's the estimated standard deviation of the sampling distribution of the sample mean according to the sample standard deviation. This means that our margin of error is 5.76 according to a respective t-score for a respective confidence level, and 4 degrees of freedom 39. This means that our confidence interval for a 95% confidence level is going to be the sample mean plus or minus the margin of error, which is 69.24 grams per day and 80.76 grams per day. In other words, we can be 95% confident. We are purported to be able to be 95% confident. That's really what I should say, but I'm trying to appease ChatGPT here. That the mean of the variable in the population is between 69.23 and 80.76. And really, I would like to put it as 69 and 81 because we're talking about individual grams. I would like to just round, but let's just see what it says. Nice job. That's correct. Yes, of course it is. The standard error equals 18 divided by the square root of 40 is around 2.85, and then the okay, so it's not formatting properly. Margin of error equals 2.02 times 2.85, 5.76. 95% confidence interval is 75 plus or minus 5.76, 69.24, and 80.76 grams per day. Tiny note, we use T, not Z, since standard deviation of the population, so population standard deviation, is unknown. With n equals 40, the difference is small. Yeah. So there you go. Ready for number 2. So I'm actually going to leave it short here. These are very dense. I want to make it sort of like a mini series here where I just go through these problems that are looking at, for example, we can take a look at the next problem here. So out of 300 surveyed adults, 114 report that they regularly read nutrition labels before purchasing packaged food, constructing 95% confidence interval for the population proportion who reads the label. That is not a sample mean, that is now a sample proportion because it's a binomial function based on successes and failures. 114 yeses and 300 minus 114 no's. So that would be 186 no's. So that would be a binomial function. If it were asking for something that was like, oh, well, give the probability that at least 2 people in the sample, if you drew another sample, said yes or something, that would be a cumulative binomial function, which you would then have to invoke the cumulative binomial function, the summation formula for that, and then you'd have to solve for that. This is what all this involves. This is the math involved behind it. And the problem that I have is that these researchers, these research scientists, most of them, they know how to conduct a study. They know how to put the methodology together. Sometimes they don't even know how to do that properly. They do improper methodology to try and investigate the problem, the question that they have. But they don't know how to interpret their actual results. They don't know how to actually do that. You have to put it into practice. And so this is what I do on a daily basis. Because I know what I'm talking about. The math is actually more important than the substance. What is the math here? But this completely ignores, by the way, statistical significance and, one-tailed versus two-tailed test. Are you looking at an absolute change in one direction, or if are you looking at a change in one direction, or are you looking at an overall deviation away, which would be two-tailed? And then statistical power and type 1 and type 2 errors. This is completely neglecting that because right now it's one step at a time, and I already skipped a few steps to make this video. So anyway, I don't usually say I hope, but I do hope this was informative. I do, because I have no idea. I have no clue if people will find this informative. However, nevertheless, it is correct. It is correct what I've done. I'm explaining to you, if you break this down, this is how these numbers are yielded. So when you see 95% CI and then 2 numbers, this is how it's yielded. If you see an SE instead of an SD, so standard error, this is what they're doing. This is the logic behind the standard error. Ridiculous in human nutrition science. You better stop reporting SE, stop reporting ME, margin of error, stop reporting confidence intervals. Use descriptive statistics and stick to it. That's what you ought to be doing. So, with that being said, if you enjoyed the video, if you found it informative, leave a like, subscribe if you haven't already to me, and if you haven't, I'm not really sure what you're doing. You're welcome for reminding you. Hit that bell notification as well so you don't miss any future uploads, because why would you want to do that? Also, buy my book, Contrainidicated, a closer look and revision of mainstream health axioms that have perpetuated illness, disorder, and disease for over a century. If you have not bought this book already, second edition is out now. Link in the description below for paperback, hardcover, ebook, and self-narrated audiobook editions, because I'm all about authenticity. Also, subscribe to the Patreon if you haven't already to gain access to 1 week early uploads, ad-free content, uncensored content, loads of antiquated videos from before I was ever a public figure, and loads of Patreon exclusive uploads whenever I was doing that once every other week or so. And also an exclusive Discord server if you're interested in that for my tier 3 members. And finally, there's a lot of morons out there online. Many of them I react to. And much of their content involves them calling themselves nutrition coaches and saying that therefore they know exactly what they're talking about with respect to fitness and nutrition. Except, did you know that it's actually entirely legal to simply call yourself a coach, and that's it. Those are the criteria for calling yourself a coach. Calling yourself a coach, that's it. Oh, hi, I'm Coach Edward Goki. Wow, that was easy. Well, that puts quite a high demand on people that actually do know what they're talking about, like myself and many others in the carnivore space, to also fight back against these people, against these people. And what is a great way of doing that? Well, I have my own ways and other people have their own ways, but what is a good way for you to be able to do this yourself? Well, fortunately, I have an ability for you to do that, which is linked in the description below, which is our carnivore certification program headed by carnivore coach Peter, who has been a health and fitness coach for over 20 years, so he definitely knows what he's doing. But he has decided to take a break from coaching clients and instead coach coaches. If you sign up to be a member of that program, you will not only get multiple modules from myself about vitamin C, cholesterol, saturated fat and heart disease, gluconeogenesis, ketogenesis, ketone metabolism, uncoupled versus coupled mitochondria, the Randall cycle, carbohydrates during exercise, and loads of other content. But also you'll get content from Dr. Abs and many other doctors in the space and many other medical professionals in the space who do know what they're talking about regarding health science. But not only that, you will also be able to become internationally accredited as a health, nutrition, and fitness coach. We are officially certified through the National Academy of Sports Medicine and the Athletics and Fitness Association of America, so this is the real deal. This allows you to be able to communicate face-to-face directly with medical practitioners of your clientele, as well as being able to acquire insurance, which is something that everyone should have always. Nothing wrong with that. And it allows you to actually fight back against the charlatans who merely are coaches, who are coaches merely because they called themselves coaches. You will actually have a certificate of your accreditation that will actually mean something. Because as much as it is a fallacy to appeal to authority, it doesn't change the fact that most people will still do exactly that. So you might as well make authority mean something and sign up to be a member of that program. Links are in the description below to get a hold of Coach Peter directly to navigate an embarkation plan. Just let him know how you heard about the program and you guys can go from there. And or you can also refer to our website below, carnivorecoachinginternational.com, to get a better glimpse of what the program is all about. But with that being said, I hope to see you there in the program. You have the ability to speak to me face to face through consultation services. You may have seen that on my YouTube endeavor here a few times. So if you want to be one of those people, you can also sign up to be a member of the program as well. Lots of perks involved. But with that being said, like I said, I hope to see you there. Join me next time when we're either reacting to morons online or actually, dissecting these problems online as well, showing how to interpret this data, showing what these numbers mean, what this is all based on, and really getting granular with the dissection and investigation of health science, really. So, till then.